Hi, in this our second equation where we're looking at solving quadratic equations by graphing. We encounter problem number 3 here, where it says we have x squared minus 8 equals 1. Now, as we've done in the past, what we'll do is we'll set our left side of the equation, the x squared minus 8, as one equation, and the right side of our equation, y equals 1, as the other. Let's go to Desmos and see what this looks like. Here on Desmos, we can see our red equation is the parabola x squared minus 8, and our green line is the line y equals 1. Our equation originally said that x squared minus 8 equals 1. So we want to find where these two, the parabola and the line, are equal, and that occurs at the point negative 3, 1 and 3, 1. Now, we don't care about the 1. We want to know the x value, where they're equal. So our answers here are going to be negative 3 and 3. Also, in this case, we're not really as interested in the x-axis intercepts here because we didn't set this equation equal to 0. We set it equal to 1, so we want to know where the y values are 1. Let's go draw this on our graph and look at other ways to solve it. So here we've graphed that, and we've identified the places where our two functions cross, and they were negative 3, 1 and 3, 1. The one we are not concerned about because we want to solve for x. Y is not in this equation. So it's the negative 3 and 3 that are our solutions. Now, if we had solved this by factoring, we would have moved our 1 over, had x squared minus 9 equals 0, factored that, set each of the factors equal to 0 using the 0 product rule, and gotten that x equals 3 and negative 3 that way. Another way we could have done it is if we would have graphed this. Let's see what that looks like on Desmos. If we would have graphed y equals x squared minus 9, then, and because that would be equal to 0, then we'd be looking for where it crosses the x-axis. And we would have, once again, our answers 3 and negative 3. All right, let's go back and try the next problem. All right, in our last problem here, it looks like we have a downward opening parabola, and we want to know where it crosses the line y equals negative 10. So we could do it this way. Graph first, y equals negative x squared plus 6x minus 4. And then also graphed on the next line, y equals negative 10. Or we could move everything to one side and set it equal to 0. So here we have a negative x squared plus 6x minus 4 equals a negative 10. I'm going to go ahead and add that 10 to both sides because so often when we solve quadratic equations, we are setting one side equal to 0. It just makes sense. So here we have x squared plus, or negative x squared plus 6x, and this would be plus 6 equals 0. Let's see where that equals 0 by graphing. Now, if we solve this by graphing, let's make sure we've got the right screen here. If we solve this by graphing, you can see that it crosses the x-axis at a negative 0.873 and a positive 6.873. So we can certainly solve it by graphing and not get exact solutions. Let's graph this on our worksheet and then solve it using the quadratic formula. So graphing this here, we can see we found our solutions to be a negative 0.873 and a positive 6.873. And that's what we wrote here. Now, if we wanted to confirm that using the quadratic formula, we would let A be negative 1, B be 6, and C be 6. Plug in the negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Cleaning that up, we get this, a negative 6 plus or minus the square root of 60 over a negative 2. Now, simplifying this can be sometimes challenging for folks. We want to remember that you can simplify the square root of 60 by looking for a perfect square number that will multiply into 60. As it turns out, 4 does multiply into 60. 4 times 15 is 60. And the square root of 4 becomes the whole number 2. So we can write this as a negative 6 plus or minus 2 root 15 over 2, which simplifies because you can factor a 2 out of both of those terms. Oops, that's a -2. And you would get -3 plus or minus the square root of 15 over a -2. Now the value of 2 can cancel each place, and this negative can just come out front. It's a -1 in the denominator. We can move that to the numerator, and you'd have this. But that becomes 3 plus or minus. The negative just, when it's positive, it'll make it negative, and when it's negative, it'll make the second term positive, the square root of 15. So these two solutions are equivalent to the ones we did above and significantly reduced. So if this were a question where you had to find the exact value, finding it by graphing will give you the decimal representation of the value, not the exact value. To get that, we needed to use the quadratic formula or completing the square. Anyway, so I hope we've provided some strategies for you to be able to solve your quadratic equations, and we appreciate your watching. Thanks for watching.